equals 16. This looks a lot like what we were doing yesterday or the day before, when we've got something where it's x squared plus 6x equals 16. We don't have just an x squared. So far our technique would be, let's make everything equal to 0 and factor. Now when I move the 16 over and go to factor, oh, this one's going to work just fine. What would you get? And we'd have to remember to equal 0. It's going to be x and x for the first ones. You're going to need an 8 and a 2. And you'd want your 8 to be positive and your 2 to be negative. And then we'll get x equals negative 8 and x equals 2. This is our factoring method. Now there's going to be some times that we're going to get an equation like this. And I'll change the number to 10 this time, where when we move it over, same technique that we had before, but when we go to factor, two numbers that multiply to 10. 5 and 2 doesn't make 6. What also multiplies to 10? 10 and 1 doesn't make 6. So we get a problem, right? Sometimes when you make it equal to 0, it can't be factored. Now you would like, I'm sure, if it can't be factored, you could just say can't be solved and you're done on the question. But that's not the case. This still can be solved. We just have to figure out how. And this is where this new technique comes in of completing the square. The idea works like this. If, I'm going to start back how I had before. I'm going to leave some space right here on both sides, because I originally had x squared plus 6x equals 10. If I could change the left side to something squared, then I could square root both sides and get rid of the squared, because I would have an x. If I could have an x in here, so that's the only place where I had an x, then I could square root both sides and get rid of that squared. If this is my first term, remember, something squared means something times something where it's the same. If I want that x to be an x squared, can you see that there would have to be an x there? What would I have to have for my last one so that my outside and inside make 6? And it has to be the same number if it's squared. 3, right? Does that make my outside and my inside give me a 6? And they would both have to be positive. So I know, man, if I had x plus 3 squared here, that would give me x squared plus 6x, but it would give me a last term. What would that last term be? 9. Now, you can't just add 9 to one side. That makes the equation not equal anymore. But if you add 9 to one side and add 9 to the other side, you're okay, right? You're allowed to do that in math. What you add something to one side, you can add to the other. It keeps the equation equal. But what do I get now? This whole thing makes a perfect square. It makes x plus 3 squared. And on this side now I have 19. Now I've got an x squared all by itself. And we can go back to the steps that we did in our first equation where we square root both sides. If I square root this side and I square root this side, here, I want green. I'll just get x plus 3. On this side, remember the plus or minus, I'll get plus or minus square root of 19. Square root of 19 is not a nice number. That's why we couldn't factor it, because factoring only works for nice numbers. Square root of 19 isn't a nice number, but now if I want to get x by itself, subtract 3 on both sides. And we get our final answer. One second. Yes. What this is called, this step right here, from here to here, is called completing the square. Because we wanted to make something a perfect square, but in order to do that, we had to add something to it to make it into a square. So once we completed the square, then we could use our new technique. What's going to happen in these questions all the time, unless the question itself says solve by completing the square, because then you know you could go to this technique right away. But what's going to happen often is you're going to start this way. You're going to say, I want to FOIL. I want to use the zero product property that we had before. So I need to move everything over, make it equal to 0, and see if I can factor. If that's the case, this is the fastest method. But we saw in this green example with the 10 over there that when I moved the 10 over and I tried to factor it, it didn't work. 5 and 2 didn't make 6, 1 and 10 didn't make 6. So then I go back to the way it was and I see if I can create a perfect square, because then I can square root both sides and use a new technique. So for these questions, we're going to have multiple techniques for quadratic equations. Sometimes we'll be able to factor. Sometimes we'll be directly able to square root both sides. Sometimes we're going to have to complete the square in order to do that. And later in this unit, we're famous quadratic formula. Excitement. I know it's building. It's a long weekend. You won't be able to learn all of this before Tuesday. How are you going to be able to survive the weekend? All right.